Hi, what I have here on the workbench today is a TOOLTOP ET12S thermal camera and DMM combo. Nowadays, manufacturers are getting quite creative. I have seen a lot of combo devices, such as oscilloscope multimeter combo and bench power supply and DMM combo. But this is actually the first time I'm seeing a thermal camera and multimeter combo. And by the way, it is also a touch screen operated device. Anyway, Banggood provided me this device for review. As usual, I will leave a product link in the video description below for those who are interested in getting one after watching this video. First thing first, the ET12S is actually very small and very light, and it can easily fit in your pocket. Here I have a standard sized multimeter, which is a Unity UT61E Plus for comparison, and you can see just how tiny this meter actually is. Now, this meter does have hard shell. It feels quite sturdy, but I don't think you want to drop it as there's no protection along the edges at all. So if you drop it, it will probably break. Also, you can see there's no stand at the back. This is the battery case, but there is no stand that you can extend. So you can either hold it or put it on its back when in operation. In the same series, there are two models, and they differ only by the IR sensor resolution. This one I have here is the ET12S. It has a thermal image resolution of 90 by 120, which is on the low side. But given that the price is just at under $140, it is actually quite competitive compared to the other thermal cameras with the same resolution. Of course, as we have seen on the channel before, the quality of the IR sensors can vary quite significantly, so we'll have to test out the image quality a little bit later. The other model, the ET11S, is considerably cheaper, but it only has a thermal resolution of 24 by 32, which in my opinion is probably a little bit too low to be useful. The multimeter spec is also pretty basic. It only has 4,000 counts and it does not support current measurement. Alright, enough said, let's power it on and take a closer look. Now the boot up time is actually quite decent. It took just around 5 seconds from the moment I press the button until it's fully operational, and that's actually not bad at all. Just by looking around, you can see that the refresh rate is actually quite adequate. And by the way, the refresh rate is spec'd at 20 frames per second. And the IR image quality is okay, but you can see, if you look at the background, that we don't have a lot of contrast, and the image is a little bit noisy as well. Unfortunately, we don't have the specifications for the NETD or noise equivalent temperature difference on the spec. For the price and thermal resolution we have, the image quality is actually pretty much what I expected. The thermal camera doesn't have a lot of bells and whistles, but you can take a picture using the button here, and it will save into a bitmap format. And later on, you can connect the camera to your PC via the USB-C connector. And by the way, you do get a USB cable with the ET12S. To transfer a file to your PC, you just need to change it to the USB mode. So let's come here, and you can see we have this USB mod manual, which is USB mode. I don't know why they don't spell it out as USB mode, as you do have enough space here. And oh, the screen does dim after a few seconds, if you notice that, and we can press it again to make it bright. I suppose that's to save battery here. And by the way, the spelling also, you can see here, some of the second words are capitalized, some of those are not. Anyway, those are just minor details. So you can use this menu item to change it to USB mode, and you can connect to your PC if you want to. And once you change it to USB mode, it will show up on your PC as a flash drive. The storage capacity is tiny though. It is only 4 megabytes. But given the low resolution, you can actually still record at least a couple hundred images. And obviously, with this low resolution, it is not meant for troubleshooting electronics. But just out of curiosity, let's actually take a look at an Arduino board. And here is an Arduino board I have powered on for a few minutes. Let's take a look here. So you can see we can discern some of the larger components here. And I probably will just overlay a picture here, as it's pretty hard to see through the camera here. And you do hear the shutter clicking, and that's normal. That's just for internal calibration of the thermal camera here. So you can see we have by the look of it, a smaller QFN here, and this is the larger chip. And towards the side here, you can see that is our regulator component. Yeah, you can see the outlines of these larger components, but there's not enough detail. Of course, that's limited by the resolution as well. So that's pretty much what I expected. You can detect hotspots, but it doesn't have enough resolution to discern small components. Also, we don't have a minimal focal length figure defined, but you can get pretty close to the object and remain in focus, which makes up for the lack of resolution, in my opinion. Now let's take a look to see if we are able to measure the temperature of the MHP30 hot plate at its maximum operating temperature of 350 degrees Celsius, as the maximum temperature we can measure on this ET12S is spec'd at 400 degrees. So let's take a look. And as you can see, we are quite a bit off. Right now we're only showing 300 degrees, and that's actually probably okay because we do have the emissivity setting, so let's actually change that. Now I don't know what the emissivity of this surface is, but let's take a look at the settings here. So IR camera, let's see, currently we set at 0.95, which is actually probably okay, but let's reduce it a little bit. Actually the temperature reading will be higher, so let's do it, for example, at 0.9, and let's go back. So I would expect the actual measured temperature to be a little bit higher now. As you can see, yeah, so that's definitely dependent on the emissivity, of course. You have to fine-tune that. But this does give you some idea that this thermal camera has no problem of measuring temperature in this temperature range. And now let's take a look at the digital multimeter mode. To switch to the multimeter mode, you just press this IR DMM button, and it will go to the multimeter mode. And by the way, you can start up by default to enter either the IR mode or the multimeter mode. So let me actually show you that. So to set that up, let's go back here and we go to the menu here. So let's see system settings. And you can see the power up currently is set up to enter into the IR mode directly. And let's switch it to the multimeter mode. So let's power it off. And now if I power back on again, you will see that immediately it enters the multimeter mode, and that actually is very fast. So if you're using multimeter primarily, then I would recommend switching the default boot up to multimeter mode. And after you get into the multimeter mode, switching to IR mode will take a few seconds. So it really is not that big deal, and it's very fast. And now let's switch back to the multimeter mode and take a closer look. I had to prop it up a little bit so you can see the display better, but in reality the display is actually not bad at all. Now it does dim after a few minutes, so let's actually press it. You can see that we're brighter here, and the viewing angle is quite good as well. I actually can see it from the side. Now the reflection from the background is a little bit annoying, so let me just keep it propped up like this. As a pocket DMM, the input sockets are on the side. As you can see here, they're on this side, not on the front. But the supplied leads, unfortunately, came with these right-angled plugs, which in my opinion, they should have supplied leads with straight-angled plugs, like the one I have here. And this would be a lot easier to work with. But anyway, in this video, we'll just use the stock leads. Anyway, like I said earlier, the specs are pretty mediocre. So let's just do a few measurements with my EDC MV216A DC voltage standard and get a sense of how accurate the readings are. So let me tap it so that it's maximum brightness. Now I'm going to just set it 1 volt at a time. 1 volt, 2, 3, 4, 5. And because this is a 4,000 count meter, you can see that we're losing 1 digit after we cross that 4 volts threshold. 6, 7, 8. So you can see that readings are a little bit off, but that's within the 1% spec accuracy. 9, 10. The ET12S does have millivolt measurement, and you can see right now we are setting the output from the voltage standard at 100 millivolts. We're reading 99.2 millivolts, and that's actually within spec. In the millivolt measurement range, the spec is actually a little bit worse. It is at 2% accuracy, so this is definitely okay. Now let's go down to, let's say, 10 millivolts. And no problem at all. Also, the update rate is actually pretty fast. So that is actually better than a lot of the meters I have reviewed on the channel. The screen went off, so that's actually one of the annoyances here. So you just tap it and it will come back. I don't remember how long it stays on. Probably there's a setting we'll have to take a look. But anyway, you can see we have this hold and range button, and you can reassign the functionality of this button to either hold or manual range selection. So let me actually show you how this is done here. So if I come to the menu and in multimeter mode, you can see here, right now the button is set to hold, and I can change it to range. So once I do that, if I come back here, this button will be able to manually change the range of the current measurement instead of holding the display value. And by default, it's set to hold, and I rarely use that function because while you are doing your measurement, you have to actually press the button to hold the value. On some more expensive meters, there is actually an auto hold functionality, which is a lot more useful. Anyway, this is great to see that we can reassign this button to do manual ranging, and that's a lot more useful, in my opinion. One feature a little bit unusual on a meter of this price range is its charting functionality. So let's take a look. I can come here and we can start charting. Unfortunately, by default, the charting is turned off. I don't know why that's the case. And it's actually not quite intuitive to use. For example, right now I turn it on. You can see that we're not doing anything. And that's because, I'm not sure if you can see this, there's a very faint play button in the background. So you actually have to tap it to start recording. So I did not know that at first, and it took me a while to figure out. I thought it was for some reason not working. But anyway, it is actually working. So let's, for example, start recording. And you can see it started charting now. So let me, for example, now hook up a 1 volt input. You will see that essentially we are recording the actual voltage. Of course, if I disconnect my lead, you can see that it dropped. Unfortunately, after I played around for a while, it seems more like a gimmick than anything useful. For example, there's no way for you to adjust the range you are measuring. Right now, for example, this range is very wide and we cannot zoom in. Also, I don't believe you have a way to export the measured data, and that's actually very important. If data points can be saved and exported to a computer, that would be a lot more useful, in my opinion. Anyway, let's do a few more measurements. So now let me change it to AC measurement mode. And let's just put the leads in the socket and see what the mains voltage is. It's 119.7. So let me do the same thing with my unit T meter. And let's AC. I will adjust the angle a little bit once I put the leads in here. So you can see the unit T is reporting 118.8. So the measurement is a little bit off. But again, remember we have that 1% accuracy, so this is definitely within spec. Now onto the ohm measurement. Let me short out the leads. Wow, did you see that? The auto ranging on this meter is actually not bad. It's pretty fast. I was not expecting that. I have reviewed a lot of meters by now, and except for a few, such as the Unity UT61E Plus and my BK Precision 2709B, most of the meters are painfully slow in resistance measurement mode, especially when doing auto ranging. Although it is only a 4000 counts meter, the auto ranging speed makes it more practical. Alright, let's just measure one resistor and get a feel of it. So this is a 100 ohm precision resistor. Of course, there's no reason need to be a precision one because we don't really have a rel button here at all. So anyway, let's just take a look. And you can see that indeed the auto ranging is pretty fast. It's obviously nowhere near the range switching speed on the Unity UT61E Plus, but this is significantly faster than most of the cheap meters I have seen for sure. Alright, let's move on to continuity testing. And it's not latched, as you can hear the scratchy sound, but nothing's wrong with that. I'd rather it being unlatched than being too slow to respond, so that's not an issue. And now let's take a look at the diode testing. So let's try a red LED as usual. No, we are not able to measure that. Let's try a regular diode here. Yeah, we are able to measure a regular silicon diode. So let's, okay. According to the manual, you can see here, yeah, diode testing is only limited to between 0 and 1.5 volts. So that's actually according to the spec. But it is a little bit disappointing to see that it's not able to light up a red LED. And finally, we have the capacitance mode. According to the manual, the highest we can measure is only 100 microfarads, which is quite low. And obviously, this range is not suited for measuring small capacitance in picofarads as well. You can see that we already have a lot of residual values here, and there's no way for us to zero it out. But let's take a look at a 22 microfarads capacitor here. Yeah, as you can see, we measured it with no problem. But I do wish we can measure larger capacitance. Alright, now let's open it up and take a look inside. Look at the anti-tampering sticker on the screw itself here. Usually, it is just a sticker over the screw hole, but they apparently have taken it up a notch here. Anyway, let's open it up. Actually, we probably need to open the battery compartment here first. Let's see that. Okay, there is a 1 amp hour battery here. Now I'm curious to see if we can measure the current draw. Let me actually open it up first. Alright, now we have opened it up. And there's actually a separate screw holding these two input jacks in place. I had to remove those in order to remove the board. So let me actually take the board out first because the battery is on the other side. So let me just tidy things up so we can measure the battery consumption here. And by the way, I really like this 01 CM2100B clamp meter. As you can see, we can get into very tight spaces here. I will leave a link so you can check out the review of that meter as well. Anyway, let's take a look at the current measurement here. So for that, I have to put this buttons on so we can turn it on. So by the look of it, in multimeter mode, we're only enjoying 18 milliamps, which is actually quite good. So given the 1 amp hour battery, in this mode it will last you for a week. And let's change it to IR mode. And you can see we're drawing only twice the amount of current. So not bad. Even at 158 milliamps, we can probably still run a full day continuously. Of course, the screen auto dims and also we have the auto power off. So you can definitely expect be able to run this for a long time without having to worry about the battery. And you can see by dimming the screen, you save about 10 milliamps. And here you can see the auto shutter in action. Let's see if I power off the unit. Now it's very hard to align the membrane button here. Let's see if the shutter closes. Yep. So that's actually quite neat. The circuit is largely what we expected here. Towards the right side, that's our digital multimeter section. As you can see, these are separated by these optocouplers. And here we have a 595 shift register. And unfortunately, the main chip is, as you can see, the markings are sanded off. We don't know exactly what chip that is, but needless to say, that's a 4,000 counts multimeter chip. And you can see on the input section, we only have very limited protection here. That's a single PTC and a relay for switching different ranges. Now that's needed because we don't have a physical rotary switch here on this meter. The range is switched by this relay. And up here, that's our main processing section. The microprocessor used here is an ET12S ARM processor. And next to it, we have a Winbound memory chip And here is our XPT2046 touchscreen controller. And towards the bottom here, you can see that's our IR sensor module. By the look of it, we have this I2C controller interface here. And on this side of the board, you can see we don't have a whole lot going on. This is our touchscreen controller, and we do have the keypads and whatnot. Interesting though, you can see the markings on this board is FR01C, and its version, by the look of it, 0.22 or 22, I can't see from this angle, and it's made actually relatively recently, August 9th this year, and it's by FieldTech.net. So presumably this board is used in multiple brands. Anyway, I hope you enjoyed the review. Like I said, the specs of this combo device is mediocre, but it does work quite well. So if for whatever reason you need a combo device like this, it's something you might look into. If you liked the video, please don't forget to give it a big thumbs up, and remember to subscribe to the channel for more videos like this in the future. I will catch up with you next time.